Assalamu alaikum. Today I'll be presenting on the Oeko leather standard, which is a global certification for ensuring leather safety, sustainability, and ethical production. This presentation is part of my coursework that is submitted to Dr. Hammad Majeed. Now we study why a leather certification needed. We know that the demand for leather goods is increasing globally, and however leather production differs from textiles, making general standards insufficient, and consumers today expect transparency and safety. So also natural leather processing involves intensive chemicals use, and legal requirements vary across the regions. That's why a dedicated certifications like Oeko leather standard is necessary. Now we study about what is Oeko leather standard. The Oeko leather standard is an independent global certification system. It applies to all leather goods, that is shoes, furniture, and other accessories, and ensures that products are free from harmful chemicals and also meet sustainability goals and comply with laws. And as we use garments, furniture, accessories, and its main goal is to protect the consumer health and to protect the environment from the different harmful substances and chemicals. Now we study about its classification, that is based on the exposure risk and the skin sensitivity level. In class 1 we study about baby products. As we know, products higher sensitivity because as we know that baby skins are most sensitive. So in class 1 we study about the baby products up to the 3 years, and in class 2 we study about the items that is directly contact with the skin, and its skin sensitivity level is also high. In class 3 we study about the products that is not directly contact with the skin, that is belts, and its sensitivity level is moderate, not high. In class 4 is for decorative items like sofas, and each class has different limits for chemicals, and its skin sensitivity level is low. Now we study about the key chemicals that we mostly use in the leather manufacturing and processing and finishing, and mostly we use heavy metals like chromium 6 is the main chemical that we use in the leather manufacturing process, lead, cadmium, mercury, and azo-dyes may release carcinogenic aromatic amines. As we know, azo-dyes, when they degrade, they release amino acids, and they are toxic and also carcinogenic, so they are very harmful for the consumers and also for the environment. Next we study about the formaldehyde. Formaldehyde is used in the finishing process of the leather that gives smoothness and the wrinkle resistant property to the leather, and is also respiratory and skin sensitizer. Next we study about the PFAS, which abbreviated as per and polyfluoroalkyl substances, and it's persistent, means they are is also called forever chemicals, persistent in the environment and bioaccumulative, and it's also toxic for the environment and also for the consumer. Phthalates and PHS, it's also carcinogenics and disrupt the endocrine system and also hormonal system in the consumers. Now we study about the analytical chemistry techniques that is used for the analysis of these chemicals, like chromatography. Different chromatography types like gas chromatography, mass spectroscopy, and HPLC, high performance liquid chromatography, that detect dyes, formaldehyde, and volatile organic substances. And spectroscopy, as we know that atomic consumption spectroscopy is used for the trace metal analysis, so it is used for high metal quantification. Next, FTIR and UV visible also identify functional groups present in the chemicals. Next, TJA and DSC, that is thermogravimetric analysis, and DSC is the differential scanning calorimetry, is also used to the thermal behavior. As we know that thermogravimetry, so it is used for the thermal behavior of the chemicals, and pH and titration methods are also used to check the acidity and the extractable contact state. 2025 updates to Oeko regulations. The upcoming changes include, as we know, that in every year, new regulations of the Oeko tax is the certification is valid for only 12 months or 1 year. So it's the updated data of 2025, that is for the April till the April, and it includes different chemicals like PFS restrictions aligned with EU's SVHC list. It means that EU is the European's laws and it's restrict the and further we study about the limit values in next slides. Bisphenol A and bisphenol S added to the restricted substance and also limit its restricted values. And microplastic testing for synthetic leather also is in 2025 regulation we study. And about these changes reflect current environmental concerns and it also conformity with REACH, that is also European law about the Oeko tax regulations. Next we study about the chemistry of key regulated substances. As we study that heavy metals are used in leather manufacturing processes, so we study about the chromium. Chromium is used in tanning to stabilize leather, but under certain conditions it can oxidize into chromium 6, which is highly toxic for the consumers and also for the environment. And Oeko tax restricts chromium 6 to less than 3 mg per kg, and there's now a shift towards vegetable tanning as a safer alternative, as we're mostly focused on the sustainable methods and protection of the environment from the harmful chemicals, carcinogenic chemicals. So chromium 3 is considered less harmful but is being phased out in favor of vegetable or synthetic tanning agents. So vegetable tanning is a safer alternative as compared to chromium. Next we study about the bisphenol A are used in the polycarbonate rayons coatings, particularly synthetic leather finishes. And bisphenol A also acts as an endocrine disruptor affecting hormone function. Means it affects the health and also the reproductive and the development system of the human. So Oeko tax has limited BPA to 10 mg per kg in leather articles under the 2025 update. According to 2025, its limit value is 10 mg per kg. Next we study about the per and polyfluoroalkyl substances. These are synthetic fluorinated compounds and they are mostly used for water, oil and stain repellency and chemically stable due to strong CF bonds, but they are mostly persistent chemicals and they are not easily degradable and also called forever chemicals that persist in the environment and cause different carcinogenic activities in the environment and very harmful for the living organisms, for the humans especially. And these are the substances of PFAS, to include their abbreviations PFHXA, PFHXSA, NME, PFHXSA. We abbreviate them further in the next slides. The focus is now on fluorinated alternatives for functional finishes, and they are also they restrict the values according to the 2025 updates, and about 25 microgram per kg, and for the other is 1 milligram per kg each. Now we study about substances of very high concerns. These are classified under REACH, as I further talking about REACH, that it's an European law. SVHs include carcinogens, mutagens and endocrine disruptors, and examples added in 2025 include is bis alpha dimethyl benzyl peroxide, that is a mutagenic agent, triphenyl phosphate, a neurotoxic flame retarder, and its limits are set at 1000 mg per kg across Oeko standards. And here are the limit values for the bisphenol A, UV328, UV320, UV326 and methoxychloro. And in this slide we also study about the previous limit and now the limit according to the 2025 leather standard. And this table shows before and after limits for chemicals like BP and UV stabilizers. Notably, BP has reduced from 100 to 10 mg per kg and UV328 down to 1 mg per kg. And these highlights Oeko commitment to strictly safety. Okay, these all the precautions and is for the safety. Next, we study about the PFAS table Oeko leather standard 2025. This table lists exact limits for specific PFAS chemicals. For example, perfluorohexanoic acid and its salts has leather limit 25 microgram per kg, and for the N-methyl perfluoro-1-hexane sulfonamide has limit value is 1 mg per kg, and for perfluorohexane sulfonamide has leather limit value is 1 mg per kg. And for the PFHXA related substances, its precursor and degradation forms is also 1 mg per kg its limit value. Now we study about the modular certification system, and this certification process is flexible and modular, covering all the processing stages. It supports integration with other Oeko systems like Eco Passport and Made in Green that we further study in green chemistry, helping lower cost and boost transparency in the supply chain that we study focused mostly in this. Next, we study about the certification process. The certification process is a 5-step process. Firstly is the application, in which customer fills out the application form and sends it together with additional documents describing the production process and with sample material like leather article to the institute. And next process is verification of the application that you send, that consumer send. The institute review all the documents and sample materials that has been provided to them. And in next step, we study about the laboratory testing. It defines testing scope in order to conduct all test needs that we study in analytical techniques. In this method, in this step, we study about the laboratory testing. And in next step, institute creates a test report and deliver the results to the applicant if tests are successful, and the applicant signs a legally binding declaration of conformity. And the last step is leather standard certification, that institute issues a leather standard by Oeko certification. Its validity period is 1 year. Now we study about the Oeko label. Okay, it includes product ID, institute name, and the product and the QR code. And the label, consumers can check the product safety online, and it's a trusted sign of chemical safety globally that these products are safe and certified by the Oeko that focused on the eco-friendly, eco-green chemistry and not carcinogenic chemicals included in this process. So it's a symbol for the trusted items that are produced by different manufacturers. Next, we study about the stakeholder benefits. Each stakeholder benefits that include manufacturers, that the main focus on this. Stakeholder, who are stakeholders? The main thing is the stakeholder is any person, group, or organization, maybe an organization that is affected by or has an interest in a product, project, or a company. Its main includes manufacturers, retailers, consumers, and regulators. Manufacturers, who are manufacturers? Actually, they want to sell safe, approved leather. And retailers, actually, they want to offer trusted and safe products. Consumers, actually, they are the buyers. They want to buy leathers that won't harm them in any way. And the regulators, actually government, that they want to protect the people and the environment both. Next, we study about the green chemistry. In green chemistry, that we mainly focus is to used to make the leather process safer. The leather, whether it is the leather manufacturing process, its finishing process, so we have to make it green, that not more harmful for the environment and for the consumers. So in this way, we use enzymatic desizing and degrazing, that we not use acidic desizing, oxidative desizing. We use enzymatic desizing, and we use different enzymes in this process. Biotanning, that we use instead of chromium, we use bio material like mimosa, chestnut, different plants, that we study that vegetable tanning instead of chromium tanning. And formaldehyde free finishes, that is the alternative for the formaldehyde. And the water based biodegradable auxiliaries. Case study about Oeko tanned leather shoe. Okay, this case highlights a chrome free leather shoe tanned with chestnut extract, that we study in the green chemistry, that we use chestnut extract, a natural product, instead of the chromium. It passed all Oeko tests like HPLC, FTIR standards, ICP-MS, and complied with the class 2 standards. As we study class 2, that is directly contact with the skin, and complied with the class 2 standards with no PFAS, chromium 6 or formaldehyde detected. It means it is Oeko tanned leather shoe that is free from any harmful chemicals, substances, carcinogenic, that cause different diseases like reproductive development issues in consumers, in organisms that uses these products. Sustainability and SDGs. Oeko supports global sustainability goals, and it aligns with SDG 3, 6, 12 and 13. SDG 3 is about good health, that consumers' health, operators' health and environment. And SDG 6 is about clean water, that about in tanning, that will not release any harmful substances that further affect the water and the aquatic life present in seas, rivers, etc. And SDG 12 is about responsible consumption, and SDG 13 is climate action, and this is done by promoting clean production and safe chemical use. And the conclusion is about that Oeko leather standard sets a global benchmark for chemical safety in leather. The 2025 updates reflect modern environmental and health priorities, and it merges toxicology, regulation, and sustainability into one strong system for responsible leather production. Thanks.